Electrolysis is a chemical process that uses electricity to drive a non-spontaneous redox reaction. An electrolytic cell is an electrochemical cell that undergoes a redox reaction when electrical energy is applied. It consists of two electrodes, which is anode and cathode, immersed in an electrolyte and connected to a source of a direct current. The difference between the Voltaic cell and electrolytic cells are: in Voltaic cell, it uses a spontaneous reaction to generate electricity. Thus, it converts the chemical energy to electrical energy. While in electrolytic cells use electricity to drive the non-spontaneous reaction. Basically, it converts the electrical energy to chemical energy. In Voltaic cell, electron is generated at anode, and this gives the anode positive charge terminals, while electron is consumed at cathode, and this gives cathode a positively charged terminals. While in electrolytic cell, electron is removed from anode, so anode will become a positively charged terminals, and electron is supplied to cathode, so cathode will become the negatively charged terminals. The electrons flows for both cells are still the same, which is from anode to cathode. So, how does an electrolytic cell operate? The direct current source supplies electrical energy to force the reaction to occur. The negatively charged ions are attracted to the positive terminals, which is anode, while the positively charged ions attracted to the negative terminals, which is cathode. At anode, oxidation process is occur, while cathode reduction process is occur. Ions are said to be discharged at the electrodes. The electrons travels through the wire from anode to cathode. So for example here, if I have a molten electrolyte, which is the sodium chloride, this molten salt only consists of two ions, which is the sodium ion and chloride ion. So the negatively charged ions, which is the chloride ion, will attract to the positively charged terminals, which is anode. So chloride ion will be discharged at anode, while the positively charged ion, which is the sodium ion, will attract to the cathode. So sodium ion will be discharged at cathode. For aqueous solution, example here I have the sodium chloride aqueous solution. There are three species present in this solution, which is the sodium ion, chloride ion, and water. So both water and the negatively charged ion will be attracted to the anode, and both positively charged ion and water will be attracted to the cathode. Since we have two different species attracted to each electrode, we need to choose which one will be discharged at the electrode. In order to do so, let's have a look at the factors that will influence the selective discharge of a species at the electrode. The first factor is the standard reduction potential of the species. When there are two half cells reaction are possible at an electrode, we are going to choose the one with more positive inert half cell for the cathode and more negative inert half cell for the anode. This is the electrochemical series that you had memorized in SPM. At cathode, if you still remember the mnemonic that you use, kalau nak kahwin mesti ada zakat fitrah supaya hubungan hidup cukup aman, you can still use this one to help you to choose which one will be discharged at cathode. But please take notes. If you look at the inert value for the calcium 2+ ion and sodium plus ion, the inert value for the calcium is more negative than sodium. So actually, the position of the calcium 2+ is higher than sodium plus. So the position of the sodium plus is below the calcium 2+. So flip these two positions, and also please take notes that between aluminum and zinc, we have the equation for water. Since water is also possible to be discharged at cathode, the equation for water at cathode is 2 moles of water plus 2 electrons produce 1 moles of hydrogen gas plus 2 moles of hydroxide ion. So here, the equation for water at cathode will release hydrogen gas and produce the hydroxide ion. So you need to memorize this equation, because if water is being discharged at cathode, you have to write down this half cell equation at cathode. So if you look at the E naught value here, going downward, okay, the E naught value is more positive, right? So the positive the E naught value, the higher the tendency for the species to be discharged. At anode, okay, so we have an ions here, okay, so just ignore the sulfate ion and the nitrate ion because these two are also an ion, so it won't be discharged at anode at all. Okay, so between the chloride ion and bromide ion, we have the equation for water if water is being discharged at anode. Okay, so these equations are in the reduction form. So the equation that you need to memorize in oxidation form is 2 moles of water produce 1 moles of oxygen gas plus 4 moles of hydrogen ion plus 4 electrons. So at anode, if water is being discharged, it will produce oxygen gas and also the hydrogen ions. So please memorize this equation. Going downward, the value of the E naught becomes more negative. So the more negative the E naught value, the higher the tendency for the species to be discharged at anode. Second factors that will influence the selective discharge of a species is the concentration of the species. But for the concentration of the species, it's only affected the discharge of anions, which is the chloride ion. Chloride ion with higher concentration are preferable to be oxidized. This is because if you look at the value of the E naught for chloride ion and water, there is not much difference. So that's why for higher concentration of the chloride ion will be discharged at anode instead of water. Even though the position of water, the E naught of water is more negative than E naught of chloride ion. The nature of electrodes will affect the ion selected to be discharged at electrodes. If inert electrode is being used, since it is an inactive electrode, it do not involve in the reaction. But if you use the active electrode, it can run on its own to perform the oxidation or reduction half reaction. For example, here, if we have the aqueous solution of copper sulfate by using the copper electrodes, so the copper electrode used is an active electrode because the copper solid at anode will dissolve and form the copper 2 plus ion. And the electrolyte contains the same ions with the metallic ions formed from the anode. Since the copper sulfate solution contains the copper 2 plus ion, sulfate ion, and water, sulfate ion and water is attracted to anode. So since sulfate ion is also an ion, sulfur is already at its highest oxidation number, so sulfate ion will not be discharged at anode. And since we have an active electrode here, copper will be discharged at anode. Since the E naught value for copper is more negative than E naught value of water. At cathode, copper will be discharged at cathode because the E naught value of copper is more positive than E naught value of water.